Math 2, here we go. We've got 7-7 SohCahToa. So what we're going to do today is we're going to review sine, cosine, and tangent ratios, and then just talk about how, when we approach a problem, we're going to decide which one we should be using, sine, cosine, or tangent. And usually, like when you guys are in class, I tell a story. So we're going to do story time. If you don't want to hear a story, just fast forward to you see me start to write. Anyways, so the very first European colony in the Americas was, now some of you might say Jamestown, but that's not correct. The first one was called Roanoke. And Roanoke is what we sometimes call the Lost Colony. So there's this group of English people, like there's like 120, 115 of them or so. They come over, they make a little colony over in Roanoke. They're like, hey, we got a colony, and stuff like that. So they make this little colony, but they start having problems. They don't have enough supplies, things like that. So their governor, John Smith, he's like, hey, I got to go get some supplies. So he goes and he's like, okay, I need to go get some supplies. So he decides to go back to England on a ship and get more supplies and get more colonists and stuff like that, and then come back to Roanoke. Well, they have a little bit of a problem. A war breaks out between England and Spain, this naval war, and he can't find a ship that's willing to bring him back to Roanoke. So it takes him like a year or two before he can finally come back to the colony. So he finally gets a colony. He's like, hey, let's go back. So he goes back, and they go across the Atlantic Ocean. He gets there to where the colony's at, and it's completely empty. Nobody's there. Can't find any of the 115, 120 people or so. They're just gone. Nobody's there. And it doesn't look like their houses have been destroyed or anything. Just people are gone. Well, he finds on a tree the word SohCahToa, like somebody had taken a knife and cut it into the tree. So he's like, they must be talking about the Croatan Indians. And that was kind of an Indian tribe that they had met. He's like, maybe they've gone to, hang out with the Indians or something. Maybe they ran out of supplies and they went to go hang out with the Native Americans that were friendly to them. So then he starts going looking for the Croatoan Indians, and he can't find them. And he can't find anybody. And his own, I think, daughter was in the colony, and his granddaughter was in the colony, and he never finds them. He keeps on hunting around, and the people with him, they're like, hey, we got to go back home, dude. We can't stay out here forever. He's like, no, we got to find him. And finally, he's convinced to head back home to England. He comes back even later, and other colonies, they all know about this lost colony of Roanoke, and they look for him. And thing is, they never find the colony. They just completely disappear off the face of the earth. No one knows what actually happened to them. So during westward expansion, as people start going west, they find this Native American tribe, and a lot of the people have blue eyes in the tribe. And what they think happened is that the colonists became Native Americans. They moved in with the Native Americans. So what's this have to do with SohCahToa? Well, the chief of the Croatan Indian tribe was named SohCahToa. And the Croatan Indians did a lot with geometric shapes and like triangles and stuff like that. And so we use Chi SohCahToa to help us remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, that story is pretty much false. I just made it up, but it's going to help us remember SohCahToa, right? Yeah. So anyways, here we go. So this is sine is opposite over hypotenuse, cosine. Yeah, so I made up most of that story. So don't tell your parents that I told you a true story about SohCahToa. Like some of that story is true, but yeah, not all of it. All right, so we're going to remember SohCahToa because it helps us remember that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and tangent is the opposite over adjacent. SohCahToa. All right, so let's say that we get to a problem and we're like, hey, we got to solve this. So what we do is we look for our angle of reference. So in this case, we are referencing the 35-degree angle. And so what we're going to do is we're going to write down which leg is the opposite leg, which leg is the adjacent leg, and where the hypotenuse is. So looking at the x, that would be the opposite leg. The 12 would be the adjacent leg. And the y would be the hypotenuse. Okay, so how do I decide if I'm going to solve for x, which one of my trig ratios to use? Well, here's my 35-degree angle. I've got opposite. I'm going to have to use that because I'm looking for x. And I can't use hypotenuse because I don't know anything about hypotenuse. So I'm going to use adjacent. So which one uses opposite and adjacent? So opposite hypotenuse, adjacent hypotenuse, opposite adjacent. I must have to use tangent for this one. So then I'll say, okay, so the tangent, and then remember we put our angle of reference, which is 35 degrees, equals, and now we do our ratio. So it's opposite over adjacent. So x over 12. So at this point, I want to get x by itself. So it looks like I should probably multiply both sides by 12. So these would like cancel out. So I'd get x is equal to, I should do that purple because it looks better. X is equal to 12 times the tangent of 35 degrees. So we'll plug that into our calculator. So 12 times tangent of 35 degrees. Comes out to 8.402494, blah, 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 blah. So we're going to say it's approximately 8.4. All right, and now we've got x. X is 8.4. Now, if I want to find y, now I do know that x is 8.4. So I could do opposite and hypotenuse. The only problem with that is the x value that we have over here is a rounded number. And anytime you use rounded numbers in your calculations, you're going to be farther and farther away from the actual answer. So we don't want to use rounded numbers. So I don't want to use this one. So if this is my angle for reference, I should use the adjacent one and y. So adjacent and hypotenuse, let's see, opposite hypotenuse, adjacent hypotenuse. Okay, so this should be cosine is adjacent over hypotenuse. So I'm going to say, okay, cosine of the angle, 35 degrees, is equal to adjacent over hypotenuse. So this would be 12 over y. Okay, and in this case, we've got the y in the denominator. That's not a good thing, but we found out in previous sections that you can just exchange the cosine 35 with the y. And that's the bell. It's all right, I got a little bit more time. So y is equal to 12 divided by the cosine of 35 degrees. And just plug that into your calculator. 12 divided by cosine 35. 14.64929507. Let's just go with 14.6. So this is approximately 14.6. Done. All right, next one. Okay, so we've got the 48-degree angle here. We got x over here. And we've got m up here. Let's go with m first. Well, here we've got a right triangle. So this is 90 over here. In a triangle, they add up to 180. So m plus 48. These two angles, the two acute angles in the right triangle, should add up to 90 degrees. So m plus 48 should equal 90 degrees. So if I subtract 48 there, I would know that m would be 42 degrees. So now that I know that m is 42 degrees, I have options. I can use the 42-degree angle as my angle of reference, or I can use the 48-degree angle as my angle of reference. It's up to you which one you want to use. You're going to get the same answer for x, whichever one you use. So up here, let's say you don't like problems where, maybe you really like cosine or something like that, or you want to set the problem differently. Or maybe sometimes, especially with tangent, you don't like having the variable in the denominator. You can always use the other angle. Anyways, let's make the angle of reference for this one 48 this time. All right, so this one would be opposite, this one would be adjacent, and this would be the hypotenuse. So this is my angle of reference. I need the x in there because I'm going to solve for it, so I need opposite. I have nothing for my adjacent, so I can't use that. And I've got my hypotenuse here. So opposite and hypotenuse, which one is that? That's so. Sine is opposite and hypotenuse. So I can write that the sine of 48 is equal to opposite over hypotenuse, so x over 27. So I can just multiply both sides by 27. And I end up with x is equal to 27 times the sine of 48. Now remember what the sine of 48 means. The sine of 48 is a scale factor for any triangle that has this 48-degree measurement in it. And sine is going to compare the opposite of the hypotenuse. Because every triangle with 48 degrees, it's a 48, 42, 90 triangle, is going to have the same scale factor. Because they're going to be similar triangles. So we're just using that scale factor and then multiplying it by 27. So we can just do 27 times sine of 48. We get 20.06. Let's just make that approximately 20.1. All right, what if I wanted to use the 42-degree angle instead? That is okay. In this case, this side would be opposite, and this side would be adjacent. And this would still be the hypotenuse. Hypotenuse is always the hypotenuse. So to solve this one, now I have adjacent hypotenuse. Well, adjacent hypotenuse is cosine. So I could have solved the same problem by saying the cosine of 42 degrees is equal to x over 27. And then multiplied both sides by 27. And then I would have gotten that x is equal to 27 times the cosine of 42. And then I plug it into my lovely calculator, 27 times cosine of 42. And I still get the same answer, 20.1, which we kind of should get the same answer because it's the same side. So we have options here. You don't have to use a specific angle. Now remember, you can never use the 90-degree angle. Sine, cosine, and tangent are only for acute angles. So you have to use one of these two angles to solve for your problem. Never use the 90. That's not going to work out great for you. All right, that's all I got for you. Math hard. See you later. Bye-bye.